All right, we're going to do some of the lesson that we started on Friday and also did yesterday. We're not going to do all of it. So I'll do a good portion of it, the remaining part, a good portion of the remaining part, but I won't finish it. So that tomorrow you'll have another video that finishes. It's going to go over the application problems involving absolute value equations, and you'll be able to do your homework tomorrow. So the video tomorrow will be really short because it just has to go over the application problems. So today I'm just going to go over 15 through 20. And then I'm going to go over how to write an absolute value equation given a graph. In other words, if I give you the answers, could you give me the equation? So you're going to work backwards. And I know these points are off because for some reason, when I printed this as a PDF, my point shifted, but we'll fix that in the video. And as I fix it, you fix it on your paper, okay? Let me get rid of that. And tomorrow, I'm going to make a video regarding these absolute value application problems. And it's only 3 of them. So we'll talk about how to set up equations, absolute value equations for these 3 application problems. And then I'll assign homework tomorrow. But for today, we're just going to work on this page and this page, guys. So let's go ahead and get started. So the main thing is to take the inside of the absolute value and set it equal to one positive version and one negative version of the number that's on the other side of the equal sign, which represents the distance, okay? But the thing is, on number 15, that the absolute value expression is not isolated. It's not by itself. So you want the absolute value expression on one side of the equal sign by itself. So in this particular case, I need to get rid of 6. There we go. I kept trying to write with it and it wouldn't do. Okay, divide both sides by 6 because it's mashed together. Mashed together means that the operation is multiplication. And to solve it, you need to do the opposite, which is division. And you're going to solve here, and you'll get the absolute value of x equals 24, guys. And I don't like writing it down on the side. So I have the absolute value of x equals to 4. So now I can focus on what's on the inside, which is x, and set it equal to a positive version of 4 and a negative version of 4. And that's all you do. All right, let's take a look at 16. For a problem like this, where you have a number that sits on the outside of absolute value, you never use the distributive property because absolute value is very different from grouping symbols, which are parentheses and brackets. So you always get rid of the number that is attached to a set of absolute value symbols by dividing. So to get rid of -2, I'm going to divide both sides by -2. Now, I know some of you are looking at this number to begin with and saying, well, I thought distance couldn't be negative. Well, distance cannot be negative, but you don't have distance alone on the left side. On the left side, you also have a -2 attached to it. So you get rid of it first. So you get rid of the stuff that's on the outside, and then you look and you see what type of absolute value equation you have. So getting rid of that -2, I end up with the absolute value of z plus 3 equals 2. And we know a negative divided by negative leaves us with a positive. So we don't have to worry about having some type of negative distance. Your distance is 7 units. But we take the inside of our absolute value expression or equation and set it equal to a positive version of 7 and a negative version of 7. So subtract 3 from both sides. So z will be equal to positive 4. And z will also be equal to -10. All right, let's take a look at 17. Make sure you're pausing the video and taking notes, guys. I'm going to rewrite 17. That's the number 1 minus the absolute value of 2w minus 4, close absolute value, equals to negative 9. Okay. Actually, I have more than the number 1 on the side with the absolute value. I'm going to go ahead and indicate to you that when you have minus absolute value and there's nothing there, put an imaginary negative 1. So I have to get rid of positive 1, and I have to get rid of negative 1. The question becomes, which one do you get rid of first? Well, if you had this, and you were trying to solve for w, which is like our absolute value expression in our case, because we're trying to solve for the absolute value expression, because we want to isolate it or get it by itself, you would get rid of 1 first by changing the sign. So you would have negative 1w equals to negative 10. And then you would divide by negative 1. Okay? And then you have your value of w. However, you don't have w. You're trying to isolate the absolute value of 2w minus 4. But you're going to do it in the same way you would isolate w here. You're going to get rid of the 1 by changing the sign and then divide by negative 1. So let's go ahead and do that. What is farther or not attached to my absolute value? That's 1. Change the sign on 1 to negative 1. What you do on one side, also do to the other. These cancel. So now I'm left with negative 1 times the absolute value of 2w minus 4 equals to negative 10. Now what you want to do is get rid of the negative 1 by dividing by negative 1 on both sides. So we'll end up with the absolute value of 2w minus 4 equals to positive 10. Now, as you can tell, I don't have enough room. See, I might be able to squeeze it in over here. Okay, now I'm going to take what's on the inside, because now I have I have only the absolute value on one side of the equation, so I can work with what's on the inside and set it equal to a positive version of 10, and I can set it equal to a negative version of 10 and solve for both. So add 4 to both sides. So we end up with 2w equals to 14. Divide both sides by 2, and w equals to 7. You just got to make sure that you get rid of all the stuff on the outside of the absolute value before you set it equal to the inside equal to a positive version and a negative version. All that stuff on the outside has to go first. All right, here you're going to add 4 to both sides. So you have 2w equals to negative 6. Divide both sides by 2, and we have a w that's equal to negative 3. So the two answers here were 7 and negative 3. Let me write that a little better. Remember, just get rid of the stuff on the outside first before you do the positive and negative version. All right, let's take a look at 18. 18, there is some stuff on the outside. You got negative 10 on the outside. Didn't mean to do that. I'll just use this. You have negative 10 on the outside. You have negative 3 on the outside. But you're trying to solve for the absolute value of h plus 5. That's what you want by itself. So what's farther away or not attached to the absolute value of h plus 5? Well, that would be the plus 3. So I would get rid of that one, the minus 3. I would get rid of that one first by changing the sign. Plus 3, plus 3. This goes left, this goes right. I would subtract, and it's more left. So I would end up with negative 80 equals to negative 10 times the absolute value of h plus 5. And then I only have to get rid of negative 10. That's the only other thing on the outside of that absolute value. Remember, we will only want the inside, what's on the inside on one side of the equation. Divide both sides by negative 10. So we get h equals to the absolute value of h plus 5. Now I only have what's on the inside. Now I can focus on the inside. So I'm going to take h plus 5 and set it equal to positive 8. And h plus 5 and set it equal to negative 8. So I'm going to subtract 5 from both sides. And here h is equal to 3. I'm going to subtract 5 from both sides. And here h is equal to negative 13. Make sure you're pausing the video and taking notes. Okay, let's take a look at 19. 19 is a little different from the others. You'll see why in a minute. All right, what stuff is on the outside? That would be 2 and 25. Well, you want to get rid of the 25 first by changing the sign. So that goes to negative 25. This goes right. This goes left. I'm going to subtract when I put the larger number on top. So I get 14. And it's more to the left. So it's negative. I'm going to bring down what's left over on the left side. 2 times the absolute value of x plus 3 equals negative 14. I'm going to divide both sides by 2. And some of you may notice something. You have to really watch for these, okay? Because here you have a negative divided by positive is a negative. But we know that absolute value represents distance. And it says that distance is equal to some negative. In this case, it says your distance is equal to negative 7. Well, that's impossible because distance can't be negative. So our answer is no solution, okay? All right, you pause the video and try number 20. All right, this is what you should have gotten for number 20. You should have changed the sign of minus 9 to plus 9 first. Getting rid of the number that's farther away from the absolute value symbols that's not attached. So I'm left with 5 times the absolute value of 4r minus 4 equals to 40. Then I'm going to get rid of the 5 that's attached. I'm going to divide both sides by 5. So I have the absolute value of 4r minus 4 equals to 8. Now I can focus on the inside. I'm going to take that expression that's on the inside and set it equal to 8. And I'm going to set it equal to negative 8. One positive version and one negative version. And each one of these is just a basic two-step. So for r, you're going to divide both sides by 4. And r is equal to 3. The other answer for r is solved the same way. It's a basic two-step equation. That's to the left, that's to the right. It's more to the left. I'm going to subtract. You get negative 4. Divide both sides by 4. And r is equal to negative 1. So your two answers again are 3 and negative 1. That's what you should have gotten. Okay, let's take a look at the last page we're going to discuss in the video today. Writing absolute value equations given a graph. In other words, if I give you the answer, write the equation. So we're going to focus on that. I don't like the way that looks. All right, so this is very easy. I'm going to give you the steps that you need to write the equation given the graph, okay? The graph of answers. First of all, you're going to find the midpoint. Okay, so you're going to look at the 2 points and calculate what is in the middle. And so it's very easy to do that. All you do is determine the number of spaces between the 2 points and then find the middle part of it. And then what you're going to do is determine the number of units each given point is from the midpoint. And that's going to represent your distance, okay? All right, this represents your distance. This is why I said this number goes on the opposite side of the equation, because on the opposite side of the equation is the distance, okay? All right, that midpoint represents how far that a certain number is away from that distance, okay? So let's take a look. And it's going to be set up like this, guys. The absolute value of x minus the midpoint equals the distance from the midpoint, all right? So let's fix these on your paper. You have, and I'm assuming it's out of whack on your paper. Let me get rid of that. I think your dots will probably like that. So let's fix them. So I want one on -5 and the other one on +3. Can I give you a chance to fix that, okay? All right, now what I'm going to do is look at this entire distance between the amount of spaces between -5 and 3. So that's 1, 2, 3, 4, 5, 6, 7, 8 units between it. So I know halfway would be just 4 units. It will be right here. That's the halfway point at -1. So you can see that on this side I have 1, 2, 3, 4 units. And on the other side, I also have 1, 2, 3, 4 units. So it is split in half. It's split in half and the midpoint is -1. Okay. So I'm going to say the distance between some number. Now I actually know those numbers, but again, I'm writing the equation. So use a variable. The distance between some number and the midpoint of -1 is equal to how many units on each side? 4 is equal to 4. That's all you do. Now I could rewrite this as the absolute value of x plus 1 equals to 4. That's it. All right, let's take a look at B. Let's fix B. And if you don't understand this, when we get back in class, you can just ask me about it again, and I'll explain it. Okay, let's get rid of these. All right, and let's put a point on -6 and a point on 8. And so suppose your answers were -6 and 8. So all I'm going to do is calculate the amount of space or distance between these two. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I know halfway would be 7 on each side. 1, 2, 3, 4, 5, 6, 7. So the midpoint obviously is -1. Or what's in the middle? Midpoint means middle. And on the other side, of course, you should also have 7. 1, 2, 3, 4, 5, 6, 7. So I have the distance between x, some number, and 1. How is the midpoint? Is going to be equal to 7 units. Remember, this is always your distance from the midpoint, and it's 7 units on each side. Each point is 7 units on each side of the midpoint. Okay, let me fix C and D, and then I'm going to have you try them, okay? Let's fix them first. Okay, let's see. Let me get rid of that. Get rid of that. Let me go ahead and get rid of these. And then we'll fix them. I want you to put a point on -1 and a point on 9. Here I want you to put a point on -9 and a point on 1. All right, go ahead and see if you can write the equation if you're given that graph of answers, okay? All right, this is what you should have gotten for C. Okay, hold on. Let's count the span. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, we know that's going to be 5 on each side. 1, 2, 3, 4, 5. My midpoint will be 4. Of course, it should be 4 on the other side. 1, 2, 3, 4. Excuse me, 5, because it was 5 here. 1, 2, 3, 4, 5. So it's x minus the midpoint equals to the distance from the midpoint on each side, which is 5. So the distance between some number and 4 is 5 units. That would be a 9 and a -1. Okay, let's take a look at D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to count halfway. 1, 2, 3, 4, 5. I think I went way too far. 1, 2, 3, 4, 5. 5 units on that side of -4. And of course, 1, 2, 3, 4, 5 units on this side of -4. -4 is my midpoint. So when I write this equation, I write the absolute value of x minus -4, or the distance between some number and -4 is exactly 5 units. Those answers will end up being 1 and -9, but this is the equation that will produce those answers. Instead of x minus -4, I'm going to write the absolute value of x plus 4 equals 5. All right, that's it for the notes for today. That's all I'm going to ask. Tomorrow we'll do these 3 application problems, and I'll allow you to work on your homework. Bring your homework in on Thursday for me, okay? And we'll talk about it. And if you have questions about anything in the notes that I did covered in the video, then just make sure you star whatever part of the notes that is so we can talk about that as well. All right, thanks, guys.